Welcome to section 4.4. We are taking an extension in section 4.4 of the factoring we did in 4.3. So I'm going to start off with a couple of review questions going through. We want to look at x squared plus 7x minus 8, and we want to put it into two binomials. We said you look at x squared, which is x and x, and then look at negative 8. Now, to get 8, I'm going to look at 1 times 8 because I know I need to get a 7. But it's negative 8, so one of these has to be negative. And I'm going to choose the negative 1 because negative 1 plus 8 equals 7. So my two binomials are x minus 1 and an x plus 8. Okay. The second type is the difference of squares that we did yesterday. But before I start, I'm going to put in a 0x in the middle. Because again, we talked about the fact that you want to always see that b term if possible, and in this case it tells me my numbers should be the same, so it adds to 0. Well, to get 25x squared, I have a 5 with one x and a 5 with another x. To get 81, sorry about that. To get 81, we use 9 and negative 9. Because 9 plus negative 9 adds to 0. So my two factors are 5x plus 9 and 5x minus 9. Okay? The third one is a little bit different, and I like this one because it looks pretty scary up front. We're going to show you it's not that bad. What we're trying to put out is what we call the greatest common factor, and we label it GCF. And it basically means what is the biggest quantity in common between all three terms. So I'm going to look at my numbers first. I have 12 and 18 and 30. And I'm looking for the biggest number that goes into all three. Well, 12 is 6 times 2. So can I take a 6 out of 18? Yes. Can I take a 6 out of 30? The answer is yes. So I'm going to pull a 6 out. And then we look at your x quantities. This has 3 x's. This has 2 x's. This has 2 x's. So they at least have 2 x's, so I'm going to pull out an x squared. And this has 1 y, 2 y's, 1 y, so they at least all have 1 y, so I'm going to pull that out as well. And this is something we've done before, so it should seem kind of familiar. 12 divided by 6 is 2. I had 3 x's, but I took away 2 of them, so I have 1 x left. I had a y, but I took the y out, so I just put a plus sign then. 18 divided by 6 is 3. I had 2 x's, but I took 2 x's out, so that's gone. I had 2 y's, and I took 1 out, so I have 1 y left. And last term, 30 divided by 6 is 5. I had 2 x's, but I took them both out. And I had 1 y, but I took that out as well, so I just closed my parentheses. This is called factoring out the greatest common factor, the GCF. And all we're trying to do is say what is in common. Normally when questions look like this, you're going to pull out the GCF and be done. Okay? Now, the harder part comes when we start factoring when we have a leading coefficient. So if you look in part A, I have this 3 out front. Here's what happens. I can no longer say that I can get 8. You know, I could say 2 and 4 or 1 and 8, but none of these will ever add up to the middle term of negative 10. And that's because there's a 3 in front. And so what I'm going to show you is what we call the snip method. And you can watch my video, and then if you feel like, I need one more explanation of that, Mr. Snip also has his video on YouTube. He's kind of the one we named that after. And so right on YouTube, you can search for the snip method, and that will be there as well. Okay, here's how the snip method works. We'd make a table where we want A times C in the first column, and we want it to add to B in the second column. Okay, so here's my A is 3, my B, let's try that again, my B is negative 10, and my C is 8. Okay, so I take A times C, 3 times 8 is 24. And I want it to add to negative 10. So what I'm going to do is list the factors of 24. Well, I know I could do 2 and 12, or 6 and 4, or 3 and 8. Those are kind of the most common. We want to see which one of those could possibly get us a 10. Well, 2 and 12 could, but only if one of them were negative, and I need either both of them to be negative or both of them to be positive in order to get a positive 24. So I'm going to go with 6 and 4, and I'm going to make them both negative, because a negative 6 times a negative 4 equals our negative 10. What happens then is we're going to take each of our factors, the negative 6 and the negative 4, and we're going to divide it by our leading coefficient of 3, our A value. Okay, so make a little note, divide by A. Okay, now I'm going to reduce this. Negative 6 divided by 3 is negative 2 over 1, and I'm going to leave it as a fraction. Negative 4 over 3 can't reduce, so I'm leaving it as negative 4 over 3. What's great about the snip method is it has now just told you your factors. My denominator is where my x goes. And the way this works is now x, and then I go up above minus 2. So I have one factor that's x minus 2, and the other factor is 3x minus 4. Now, what would happen is, these are my two factors. If I were to FOIL this, I should get 3x squared minus 10x plus 8 that we started with. Okay? So the snip method allows us to easily factor when there's a number in front of the x squared. So let's try another one. In this case, my A is 4, my B is 12, and my C is 5. Now you'll notice the multiples of 5, 1 and 5, can never add to be 12, so I start thinking about the snip method. Okay, well, A times C, 4 times 5 is 20, and I need that to add to 12. Well, the ways to get 20 are 4 times 5, 1 and 20, or 2 and 10. And 2 times 10 can get me the 12 that I'm looking for. So let me go through that one more time. What I need to do now is take 2 and 10, which are our factors, and we always divide it by the value of A, which is 4. I reduce my fractions, so 2 divided by 4 is the same thing as 1/2. 10 divided by 4, if you divide it by 2, is 5/2. And now that they are in reduced form, I can put an x on the bottom and write my factors. So 2x plus 1 times 2x plus 5. And the order doesn't matter as long as the 2x plus 1 is a factor and the 2x plus 5 is a factor. Okay? Let's do one more. In number C, A is 6, B is 1, C is negative 15. So I make my table. AC has to equal B. So 6 times negative 15 is negative 90. And somehow that's got to equal 1. Okay, so 90. I could have 3 and 30, or 2 and 45, or 10 and 9. And I'm going to use 10 and 9 because 10 and 9 can somehow get me 1. Now the problem is I need a negative 90, so the 9 has to be negative, because then 10 minus 9 is 1. So I take my factors, 10 and negative 9, and I divide each by my A value, my leading coefficient, and I reduce. 10 divided by 6 reduces to 5 over 3. I can put an x there. Negative 9 divided by 6 reduces to negative 3 over 2. I can put an x there. So my two factors are 3x plus 5, and let's try and write this correctly, 2x minus 3. And again, if you're looking at me going, really, how does that work? I promise you, FOIL it out and you will find you get back to the original. Okay, so this is our introduction to the snip method. What I'm going to do now is kind of talk about a couple of different options, and then I'll give you guys some to try as well. Okay, so let's scroll down. All right, taking a look at D. What you can do if you want automatically is to start the snip method because there's a number in front. However, take a look at the numbers that are there. If you look at 4 and 10 and 6, you can divide each of them by 2. And so what I'm going to do is pull a 2 out front, and I then have 2x squared minus 5x minus 3 equals 0. And it's easier to use the snip method when you have smaller numbers as opposed to bigger numbers. Now it still works out, but if you can pull something out, that's your first step. So now I'm going to use the snip method with this. So my a is 2, my b is -5, and my c is -3. All right, so according to my table, a times c is -6, b equals -5. Now, in order to get -6, -6 and 1 is the best combination because -6 times plus 1 is -5. And I take each and I divide it by my new leading coefficient of 2. The 2 that's out front, in the end, doesn't necessarily matter. We're just going to use it once we get our final answer. Okay, now this is already reduced. The 1/2 is already reduced, so I'm going to put my x there. The -6 over 2 reduces to -3 over 1, so I can put an x there. What this says are my two factors are x minus 3 and 2x plus 1. And the only thing that's not included in here is the original 2 we pulled out, so that 2 should come in front. If you don't put that 2 in front, you are not going to get back to the original when you FOIL it. Okay? Now, the one step we didn't do is you now see an equal sign. So I'm going to go back to section 3 a second and talk about how to solve this. We said set each piece equal to 0 and solve. So if there's an equal sign, you actually set it equal to 0. The 2 doesn't matter because if I look at this and I say, does 2 equal 0, you're going to look at me and go, no. So I don't care about that one. When x minus 3 equals 0, x equals 3. When 2x plus 1 equals 0, you can solve this and you get that x is -1/2. So again, you have two solutions because you started with an x squared. Okay, so keep that in mind. What I want to do is have you do question number E, or letter E, but the only thing I'm going to do is going to start you off. If you look at 21, 77, and 28, they all have a 7 in common. So if I divide each of them by 7, I get 3x squared minus 11x minus 4. What I want you to do is use the snip method to factor it, like we did here, and then I want you to solve in order to find what x equals. Okay, so this is an on your own one, and if you want the notes points, well really just for better understanding, we want you to do letter E. Okay, pause the video, take a second and do letter E, and then when you're ready, flip the page. All right, we're to the back side now. You'll notice in number 1 we need to factor it. The problem is there's only 2 terms. And because there's only 2 terms, we want to pull out the greatest common factor. Okay, so what do they have in common? Well, they each have a 7 in them, and they each have an x. Because this is a -7, I'm going to take the negative with it. Truthfully, because I just think it's easier once we factor in the end. Okay, now if I take out a -7x, I took out the -7, I took out 1x, so I have 1x remaining. -63 divided by -7 is a +9, and I took the x out. This is my factoring. Okay. Number 2, first of all, let's look for is anything in common. Well, they each are divisible by 5. Because this is negative, I'm going to take that out too. So I'm going to take a -5 out. And if I divide -25 by -5, I get a 5 and I keep my y squared. 60 divided by -5 is a -12 and I keep my y. -35 divided by -5 is a +7. Okay, now this has a coefficient still of 5, so we're going to work with the snip method. So I do A times C has to equal B. 5 times 7 is 35. It's got to add to negative 12. Well, how do you get 35? I think the one we think of the most is 5 times 7. If it's a positive 35, I could do negative 5 and negative 7, because a negative times a negative equals a positive. And this ends up equaling negative 12 when you add them. So I have negative 7 and a negative 5, and I divide it all by my leading coefficient of 5. This is reduced. This one I can reduce to negative 1 over 1, so I put an x there. So my two factors are 5x minus 7 and x minus 1. The only thing we don't want to forget is the 5 that we pulled out, the negative 5, and so there's our factors. Okay? What I'm going to do is we're going to use number 3 and number 4 as a warm-up tomorrow in class. So if you want to make sure you can do it or give it a try before we get to class, that would be my suggestion, but I'm going to stop the video for there today. So thanks for watching 4-4.